Welcome to today's Explainer, where we are unpacking Ian Staley's groundbreaking working paper on securing autonomous AI agents within blockchain environments. Look, the economic role of artificial intelligence has shifted dramatically, and frankly, the pace is just staggering. I mean, in just the last 24 months, we've gone from being totally amazed by passive language models that can, draft an email or summarize a PDF, to deploying active, semi-autonomous agents that are out there right now, negotiating terms, trading assets, and disposing of real funds. But here's the massive roadblock we're hitting. Our current financial infrastructure was built entirely for humans making conscious decisions. It was absolutely not built for autonomous software operating at light speed.
Staley really hits the nail on the head right away, pointing out this massive existential threat. Handing an AI traditional crypto tools is basically a ticking time bomb. See, the conventional crypto model relies on a useful fiction. It assumes that whoever holds the private key is a legitimate, conscious human decision maker. But when an AI agent holds a key with full transfer authority, well, as Staley notes, it is a single point of catastrophic and undetectable failure. Just imagine the fallout here for a second. Imagine an AI quietly draining a multi-million-dollar corporate treasury, funneling it away in seconds. The blockchain wouldn't care. It just sees a mathematically perfect cryptographic signature. No alarms, no block transactions. You wouldn't just hand a robot the physical keys to a bank vault without establishing some serious rules, right? So why on earth are we doing it on-chain?
So, here is our roadmap for bridging this critical infrastructure gap today. We'll hit the AI wallet problem, move into Know Your Agent, break down the 5-layer architecture, talk about intents over transactions, and finally see how this works with agents in the real world.
All right, part 1, the AI wallet problem. Let's really dig into the baseline risk of our current setup.
Handing an agent a standard private key is exactly like giving a brand new employee a blank, signed corporate check. It creates an absolutely unacceptable risk for any serious organization. Think about how heavily fragmented the current landscape actually is. On one side, we have traditional banking, where an employee gets a corporate card with super strict spending limits, specific merchant categories, and multi-signature approval workflows. On the other side, you've got crypto-native open standards where holding the key equals absolute, unyielding control. If you try to bridge these two worlds by simply handing an AI a traditional crypto wallet, you are stripping away every single one of those essential corporate guardrails. It just doesn't offer the bounded, revocable authority that institutional operations actually need to function safely.
Before we go any further, let's do a quick vocabulary check on the 3 distinct players in this new automated economy. First up, we have the agent. Think of the agent as your autonomous middle manager. This is the software actor out there making trades, paying invoices, or rebalancing portfolios while you're asleep. They formulate strategies and take action without needing you to click approve on every single thing they do.
Next up is the principal. In this scenario, that's you. You are the human, the company, or the DAO putting your actual capital on the line. Because you are the one granting the agent its authority, you shoulder the ultimate responsibility. The principal is the definitive source of truth and accountability for whatever that agent decides to execute out there in the wild.
And the third piece of the puzzle is the solver. If the agent is the manager barking orders, the solver is the specialized contractor figuring out the safest, cheapest route to actually get the job done. The solver takes a high-level goal from the agent and translates it into the technical on-chain mechanics, all while strictly adhering to the guardrails put in place by you, the principal.
So, how do we tether these fast-moving autonomous agents to the real-world responsibilities of the principal? That brings us to part 2, Know Your Agent.
Enter Know Your Agent, or KYA. This acts exactly like that tightly controlled corporate spending card we talked about, finally replacing the dangerous blank check. Drawing on a framework originally highlighted by Andreessen Horowitz's research team, Staley explains that the industry is completely missing this crucial KYA layer right now. Just like KYC establishes trust for humans, KYA uses cryptographically signed credentials to bind an agent securely to its principal, its specific permissions, and its reputation. It sets incredibly strict machine-checkable boundaries. As a concrete example, before an agent can execute a trade, a smart contract can instantly verify if the agent's KYA credential actually allows it to spend 1,000 USDC today. If it doesn't, the transaction is physically impossible, period.
To enforce this KYA framework out in the wild, Staley proposes a really elegant 5-layer reference architecture, which is part 3.
This methodical stack moves functionally from absolute cryptographic identity at the very base, all the way up to the agent's complex reasoning at the top. Let's break these down real quick. Layer 1 is identity. This establishes definitively who the agent is and who they represent. Layer 2 is policy, outlining exactly what they are allowed to do. Layer 3 is custody,
controlling where the assets actually sit. Layer 4 is payments, which handles how the agent asks to move money. And finally, Layer 5 is the agent itself, the actual logic or large language model making the high-level decisions.
When you map out the full control plane, you can really see how every upper layer completely relies on the cryptographic trust boundaries established below it. Notice how Layer 2, policy, sits right in the dead center as a cross-cutting control rail. It acts as the ultimate bouncer. It binds the permissions directly to the identity claims at Layer 1, while simultaneously constraining the actual physical settlement of assets at Layer 3 and policing the payment requests at Layer 4. The whole shebang is bound by tight, unforgeable cryptography, rather than just flimsy procedural guidelines that an AI could accidentally ignore.
Actually, notice how this completely flips the traditional Web3 script. In an autonomous economy, verified identity, not the physical network, has to be the ultimate bedrock. Staley explicitly notes that this inverts the classic OSI mental model, where physical infrastructure is always at the very bottom. Why is this such a big paradigm shift? Well, when humans aren't pressing the buttons and autonomous software is flying around at 1,000,000 miles an hour, literally nothing in the upper layers means a thing without a verifiable subject to attribute it to. If you don't know exactly who is acting, the transaction doesn't matter. Identity anchors absolutely everything here.
Now we arrive at part 4, intents over transactions, which addresses a massive shift in how these agents interact with finance.
Because really, if agents aren't writing raw blockchain transactions themselves, how on earth are they executing complex financial maneuvers across wildly different networks? We have to remember how much friction exists in crypto right now. Constructing a raw transaction couples an agent to a very specific chain, a specific gas regime, and highly complex routing logic. Expecting an AI to manage all of that perfectly every single time is a recipe for disaster. Plus, it's incredibly difficult for a policy engine to evaluate all that safely before the execution actually happens.
It basically boils down to the difference between dangerous micromanagement and simply declaring a desired end state. Contrast the absolute nightmare of coding an AI to perfectly handle Ethereum gas fees, slippage tolerance, and cross-chain routing versus simply issuing a declarative intent. With the intent abstraction, the agent just expresses what should happen, like, hey, settle invoice 4471 in USDC within 24 hours. It's then up to our solver, heavily constrained by Layer 2 policies, to determine the absolute safest, most efficient path to execute that against Layer 3 custody. This is a real game changer because it makes the agent's logic entirely portable. It can scale across EVM, Solana, Canton, or the XRP ledger without ever rewriting the AI's core programming.
Let's take all this theoretical architecture and ground it, moving to part 5, agents in the real world. If you look at the Canton network's architecture, you'll see a strict, deliberate separation between the foundational identity registries and the intent-based payments layer. Staley points out two parallel Canton proposals originating from early 2026. On one side, there's the P402 trust layer acting exactly as Layer 1, keeping strict privacy over agent capabilities. On the other side, an X402 facilitator manages the Layer 4 payments. This perfectly validates the whole theory. Independent developer teams, working on real-world institutional problems, organically partition their infrastructure right along the exact L1 and L4 boundaries proposed in this paper. Let's walk through how the baton is seamlessly passed from a human to specialized AIs using a $100,000 tokenized asset. Step 1. A human commercial borrower originates an invoice. Step 2. Highly specialized agents instantly jump into action. An underwriting agent mathematically scores the risk, while a treasury agent checks the portfolio and decides to buy the invoice. Step 3. The treasury agent issues an intent, and a solver agent figures out the mechanics. Finally, Step 4. A reconciliation agent jumps in to ensure the incoming payments perfectly match up. Following the flow of capital and data here is just fascinating. The institutional investor simply sets a mandate at the very top. Multiple specialized AI agents operate composably, passing the task down the chain, without a single one of them ever holding a raw private key. The agents issue Layer 4 intents to acquire fractional interests. Solvers pick those up, assemble the necessary attestations, and execute the transfer at Layer 3, entirely boxed in by Layer 2 governance policies. Crucially, and this is really the ultimate payoff of this entire architecture, this all happens under designated cryptographic visibility for regulators, exactly like the Bank for International Settlements has been asking for. So I'll leave you with this provocative thought to ponder today. The agentic economy isn't some far-off sci-fi future, it is literally happening right now. And the blank checks must be revoked today. We are actively moving from a world of identification without trust to a fully verifiable, intent-driven 5-layer control plane. Understanding how identity, policy, custody, and payments compose isn't just academic theory anymore. It's the foundational requirement for surviving and scaling in the next era of digital finance. Take a hard look at your own systems and ask yourself if you are truly ready. Thanks so much for joining me on this explainer, and I hope this gives you a powerful new framework for thinking about AI on the blockchain.